right, so this is 5.2, part 1. The web assign for 5.2 is part 1 and part 2 together. So it's going to be due on Monday because we'll do part 2 tomorrow. But we're just going to do part 1 now. So if you get to questions in the web assign that we didn't talk about today, it's because we'll talk about them tomorrow. But looking at part 1, we're going to start by talking about our trig ratios. Trig ratios come from our SOHCAHTOA that you've heard before. You did this in geometry, algebra 2, so you've seen this before. This stands for sine is opposite over hypotenuse, which is what's written here. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now we have our reciprocal functions. So sine and cosecant are reciprocals of each other. So if it asks for cosecant, it'll be the flip of sine. Instead of being opposite over hypotenuse, it'll be hypotenuse over opposite. Cosine and secant are reciprocals of each other. And then tangent and cotangent are reciprocals of each other. Now, the opposite and adjacent depend on where your theta is. So it'll give us an angle theta. So here are thetas down here. Opposite is the side that is not touching theta at all. Adjacent's the one that's right next to theta. And our hypotenuse is going to be opposite of the right angle. So we'll have right angles here. Hypotenuse is going to be opposite of the right angle. The opposite sides, opposite of theta. And then adjacent is going to be the other one, the one that's right next to theta. That's not the hypotenuse. So here it just does an example of sine for us. So theta's down here. So our 3 would be opposite, 5 would be the hypotenuse, and 4 would be our adjacent. So when we do SOHCAHTOA, sine is opposite over hypotenuse. So that would be 3 over 5, which it gives us here. What would cosine be? Cosine's adjacent over hypotenuse, so that would be 4 over 5. Perfect. And then tangent is opposite over adjacent. What would our opposite over adjacent be? 3 over 4. Perfect. So we're going to be doing more examples of this on the next page. So example 1 says, find the 6 trig ratios of angle theta. So we want to find sine, cosine, tangent, and then our reciprocal functions, which are going to be cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, and then cotangent is the reciprocal of tangent. So with theta being down here, what is 3? Is it the opposite, adjacent, hypotenuse? 3 would be our hypotenuse, perfect. What about 2? 2 would be our opposite, and square root 5 is adjacent. Awesome. I think it's super helpful to label everything first. That way you can just plug everything into your SOHCAHTOA. So starting with sine. Sine is opposite over hypotenuse. What would our opposite over hypotenuse be? 2 over 3. Awesome. What about cosine? Cosine's adjacent over hypotenuse. What would our adjacent over hypotenuse be? Square root 5 over 3. Perfect. And then our opposite over adjacent would be what? What's our opposite over adjacent? 2 over square root 5. Now, can we leave a square root in our denominator? No, we have to rationalize. What do we multiply by to get the square root out of our denominator? So we multiply the top and the bottom by square root 5. So up top, we get 2 square root 5. And then what's square root 5 times square root 5?
5.
5. Perfect. Now let's find our reciprocal functions. So sine is just the flip of cosecant, or cosecant's the flip of sine. So instead of being 2 over 3, cosecant will be 3 over 2. Secant's the reciprocal of cosine, so this would flip to 3 over square root 5. But can we keep a square root in our denominator? No, we have to rationalize. So multiply the top and the bottom by square root 5. So we get 3 square root 5 over 5. And then cotangent's the reciprocal of tangent. I'm going to flip the one before I rationalize. So flip the original. This would give us square root 5 over 2. So these would be our 6 trig functions here. All right, let's look at number 4. So we're going to find all 6 trig functions, exact values only, no decimals. So looking at number 1. Theta's down here now. So what would 13 be? Opposite, adjacent, hypotenuse. 13 would be our hypotenuse. What about 5? 5 would be our opposite because it's opposite of the theta. And then what about 12? Adjacent. Perfect. Let's find all of our trig functions now. So sine, cosine, tangent, and then cosecant, secant, cotangent. So we'll start with our 3 main trig functions because that just comes from SOHCAHTOA. Then we'll do our reciprocal functions. We just flip the 3 main trig functions. So sine would be opposite over hypotenuse. What's our opposite over hypotenuse? What would our opposite over hypotenuse be here? 5 over 13. Perfect. Cosine is adjacent over hypotenuse. What's our adjacent over hypotenuse? 12 over 13. Tangent is opposite over adjacent. What's our opposite over adjacent? 5 over 12. Now with our reciprocal functions, we're just going to flip the 3 main trig functions that we have. So cosecant goes with sine. So instead of being 5 over 3, or 5 over 13, it'll be 13 over 5. Secant goes with cosine. So instead of 12 over 13, it'll be 13 over 12. And cotangent goes with tangent. So instead of 5 over 12, it'll be 12 over 5. Now looking at number 2, it only gives us 2 of the sides of the triangle here. How do you think I could find the third side? Anybody remember? Pythagorean theorem. Perfect. Our Pythagorean theorem is a squared plus b squared equals c squared. So it doesn't matter which one's your a or which one's your b, but c matters. C is always going to be your hypotenuse. So I'm going to say 5 squared plus 8 squared equals x squared. So 25 plus 64 is equal to x squared. 25 plus 64 would be 89 equals x squared. Take the square root. Always, always, always simplify your radical if you can. Can we simplify the square root of 89? Nope, we can't. So this would be our x. So square root 89. Now let's label what our opposite, adjacent, and hypotenuse are. So theta's down here now. What would 5 be? Opposite, perfect. What about 8? Adjacent. And then square root 89? Hypotenuse. So let's find our 6 trig functions now. So sine, cosine, tangent. And our reciprocal functions are going to be cosecant, secant, cotangent. So according to SOHCAHTOA, sine is opposite over hypotenuse. What would our opposite over hypotenuse be? 5 over square root 89. Can we leave a square root in our denominator? No, so we got to rationalize. We have to multiply by square root 89 on the top and the bottom. So we get 5 square root 89 over 89. Next, let's find cosine. Cosine is adjacent over hypotenuse. What's our adjacent over hypotenuse?
8 over 5.
What's our hypotenuse?
8 over 89 square root.
8 over square root 89. Again, here we got to rationalize, so we're going to multiply the top and the bottom by square root 89 because we can't leave a square root in our denominator. So 8 square root 89 over 89. Tangent is opposite over adjacent. What would our opposite over adjacent be? 5 over 8, perfect. All right, let's find our reciprocal functions. So cosecant, I'm going to flip sine. I'm going to flip the original before I rationalize. That way I don't have to re-rationalize. So when we flip our sine, we get square root 89 over 5. Secant, we're going to flip cosine. So we get square root 89 over 8. And then cotangent, we're going to flip tangent. So we get 8 over 5. So with number 4, let's find our missing side first. So we have to do Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared, where c has to be the hypotenuse. A and b, it doesn't matter which one's which. It's going to be your two legs of the triangle. So I'm going to say a is square root 3 squared plus x squared equals our hypotenuse squared, which is 8 squared. Now you have to be careful here. What is square root 3 squared? Would be square root 9. What's the square root of 9? 3. The square root and the squared just cancel out. So we're just left with 3. Plus x squared equals 64. Subtract both sides by 3. So we get x squared equals 61. Take the square root. Can I simplify the square root of 61? No. Always simplify if it can be. Here it doesn't simplify, so it's just square root of 61. All right, so theta's down here. What would square root 3 be? Opposite, adjacent, hypotenuse? Opposite. What about square root 61? Adjacent. And then 8? Hypotenuse. So let's find our trig functions now. So we've got sine, cosine, tangent, cosecant, secant, cotangent. Now according to SOHCAHTOA, I'll write it again up here for us. SOHCAHTOA. Sine would be what over what? Square root 3 over 8. Can we leave our answer like this? Yep. We just can't leave it if it has a square root in the denominator, but this is fine. Cosine, adjacent over hypotenuse. What would our adjacent over hypotenuse be? Square root 61 over 8. Perfect. And then tangent is opposite over adjacent. So what's our opposite over adjacent? Square root 3 over square root 61. Now we can't leave a square root in our denominator, so what would we multiply by here to get rid of that square root from the denominator? Square root 61 to the top and the bottom. Now this one's a little bit different than what we were doing before because up top we have 2 square roots. So we can actually combine these together under the same square root, but we just have to multiply the 2 numbers together. So we have 61 times 3, which would be 183. So 183. Always make sure we can't simplify this square root, so we just leave it the way it is. And then this would be over, what's our new denominator? 61. So if you're multiplying two square roots together, you can actually combine them, multiply the numbers together. In the other example, we had a whole number and a square root. So for the example up here, we had 5 times square root 89, which was just 5 square root 89. You can't combine a whole number and a square root. All right, let's flip them for our reciprocal functions. So cosecant is the reciprocal of sine. So it would flip to 8 over square root 3. Can I leave my answer like this? No, we have to rationalize. So multiply the top and the bottom by square root 3. So we get 8 square root 3 over 3. Secant's the reciprocal of cosine. So flip it. We get 8 over square root 61. Multiply the top and the bottom by square root 61. So 8 square root 61 over 61. Yes. Yeah. And then cotangent's the reciprocal of tangent. So we're going to flip it before we rationalize. So that would be square root 61 over square root 3. Can I leave my answer like this? Nope, we have to rationalize. Multiply the top and the bottom by square root 3. The numerator, we can actually multiply those together and combine them under the same radical. So 61 times 3, we just did that, is 183. Over square root 3 times square root 3 would be 3. So
When you looked at 8,
what?
what do you think off the 8 when you flip it? Wait, there's 8 on that one?
No, it's just square root 3 over square root 61.
Oh.
So here are 6 trig functions. So when we find our trig functions in the calculator, our calculator only has sine, cosine, and tangent buttons. But for our reciprocal functions, we can still find the cosecant of a number, but we have to do a little bit more math with it. So for our reciprocal functions, cosecant is going to be 1 divided by sine. If it asks for the secant, we do 1 divided by cosine. And if it asks for the cotangent, we do 1 divided by tangent. So there's just an extra step when it's not one of the buttons in our calculator. If it's not sine, cosine, or tangent, we got to do that extra step and just divide 1 by the trig function that it's paired with.
And the t stands for number.
Yeah, t will be the number that we plug in. So on the next page, let's do A. So here we have the tangent of 40. In your calculator, you have 2 modes. Your calculator will either say DEG, that means that it's in degrees, or it'll say RAD, that means that it's in radians. There are some questions on the WebAssign that make you go back and forth between degrees and radians. In my calculator, which I think most people have this one, the TI 30X, most people have this one, but a lot of the calculators are the same. To change from degree to radian, mine has a DRG button. If you click on that, you can scroll to change it to the radians. So for the homework, some of the questions will be in radians. So you just want to change your mode to radians. So mine, to change the mode, I have a DRG button. It's right up at the top here.
Depending what mode you should use.
If it gives you degrees, your calculator needs to be in degrees. If it gives you a radian, your calculator needs to be in radians. So if we're looking at A, B, and C, and D here, all of these are degrees, so my calculator should be in degrees. So for these A, B, C, and D, our calculator needs to be in degrees. Same with 1, 2, and 3. All of these questions are degrees, so make sure your calculator has that DEG button. If you have questions about your specific calculator, you can ask me when we're done with this. So for A, we want to do the tangent of 40. So I just click tangent 40. That should give you 0.8, what does it say, 3 decimal places? 4 decimal places. 0.8391. Then in our calculator, we want to do cosine of 20. So just cosine 20. That should give you 0.9397. Cotangent, we don't have a cotangent button in our calculator, so this is the one where we have to do that extra step. Cotangent's the reciprocal of which trig function? Tangent. So I'm going to do 1 divided by the tangent of 14. So in my calculator, I have to do 1 divided by tangent 14. That should give you 4.0108. Any questions on that one? Cosecant. We don't have a cosecant button in our calculator. Cosecant's the reciprocal of which trig function? Cosecant's the reciprocal of which trig function? Sine. Perfect. So we're going to do 1 divided by sine of 80. We're going to put this into the calculator. So 1 divided by sine of 80. And you should get 1.0154. Any questions there? All right, let's do the last 4. Cosine, we've got a cosine button in our calculator, so we're just going to do cosine of 52. So it would be 0.6157. Cotangent, we don't have a cotangent button in our calculator. What's the reciprocal of cotangent? Tangent. So this would be 1 divided by the tangent of 78. So in our calculator, we're going to do 1 divided by tangent of 78. That should give you 0.2126. And then last one here, secant is the reciprocal of which trig function? Cosine. So we're going to do 1 divided by cosine of 34. So in the calculator, 1 divided by cosine 34. That gives us 1.2062.